In this video, the following topics will be covered: classification and decision tree induction. Techniques for data classification such as decision tree classifiers, Bayesian classifiers, rule-based classifiers, and so on. Various the measures of accuracy are given, as well as techniques for obtaining reliable accuracy estimates. Suppose that the marketing manager wants to predict how much a given customer will spend during the sale at electronic shop. This data analysis task is example of numeric prediction, where the model is constructed predicts a continuous valued function or ordered value as opposed to a class label. This model is a predictor, or regression analysis is a statistical methodology that is most often used for numeric prediction. Approach to classification. Data classification is a two-step process consisting of a learning step and a classification step, where the model is used to predict the class labels for a given data. In the first step, the classifier is built describing a predetermined set of data classes or concepts. This is the learning step, where a classification algorithm builds the classifier by analyzing or learning from a training set made up of database tuples and their associated class labels. A tuple X is represented by an n-dimensional attribute vector depicting n measurements made on the tuple from n database attributes. Each tuple X is assumed to belong to a predefined class as determined by another database attribute called the class label attribute. The class label attribute is discrete valued and unordered. It is categorical in that each value serves as a category or class. The individual tuples making up the training set are referred to as training tuples. Step of the classification process can also be viewed as a learning of a mapping function y equal to f of x that can predict the associated class label y of a given tuple x. In this view, we wish to learn a mapping or function that separates the data classes. Typically, this mapping is represented in the form of classification rules, decision trees, or mathematical formula. In this example, the mapping is represented as classification rules that identify loan applications as being either safe or risky. The rules can be used to categorize the future data tuples as well as provide deeper insight into the data contents. What about the classification accuracy is? In the second step, the model is used for classification. This is shown in the diagram as a second, the bottom diagram B. The first, the predictive accuracy of the classifier is estimated. If we are to use the training set to measure the classifier's accuracy, this estimate would likely to be optimistic because the classifier tends to overfit the data. Therefore, a test set is used made up of the test tuples and their associated class label. They are independent of the training tuple, meaning that they were not used to construct the classifier. The accuracy of a classifier on a given test set is the percentage of test tuples that are correctly classified by the classifier. The associated class label of each test tuple is compared with the learned classifier's class prediction for that tuple. And this describes the several methods for estimating classifier accuracy. If the accuracy of the classifier is considered acceptable, the classifier can be used to classify future data tuples for which the class label is not known. Supervised learning and unsupervised learning. Supervision means the training data are accompanied by the labels. Unsupervised learning means it's a clustering process. The class labels of training data is unknown, given a set of measurements, observations, etc. The classification of accuracy. The classifier tends to overfit the data. The test set is used, made up of test tuples and their associated class label. They are independent of the training tuples. They were not used to construct the classifiers. Induction. Decision tree induction is the learning of decision trees from class labeled training tuples. A decision tree is flowchart-like tree structure where each internal node denotes a test on an attribute, each branch represents an outcome of the test, and each leaf node holds a class label. The topmost node in a tree is the root node. How are decision trees used for classification? Given a tuple X for which the associated class label is unknown, the attribute values of the tuple are tested against the decision tree. A path is traced from the root to a leaf node which holds the class prediction for the tuple. Decision trees can easily be converted to classification rules. Decision tree classifier is so popular. The construction of decision tree classifiers does not require any domain knowledge or parameter setting and therefore is appropriate for exploratory knowledge discovery. Decision trees can handle multi-dimensional data. Their representation of acquired knowledge in tree form is intuitive and generally easy to assimilate by humans. The learning and classification steps of decision tree induction are simple and fast. In general, decision tree classifiers have good accuracy. Induction. During the late 1970s and early 1980s, Rose Quinlan, a researcher in machine learning, developed a decision tree algorithm known as ID3 iterative dichotomizer. Stone and Quinlan later presented C4.5 algorithm. It's a successor of ID3 algorithm. In 1984, a group of statisticians, Friedman, Olsztyn, and Stone, published the book called Classification and Regression Trees, known as CART, which described the generation of binary decision tree. ID3, C4.5, and CART adopt the greedy approach in which decision trees are constructed in a top-down, recursive, and divide and conquer manner. The algorithm is called with three parameters: D, attribute list, and attribute selection method. We refer to D as a data partition. Initially, it is a complete set of training tuples and their associated class labels. The parameter attribute list is a list of attributes describing the tuples. Attribute selection method specifies a heuristic procedure for selecting the attribute that best discriminates the given tuples according to the class. The procedure employs an attribute selection measure such as information gain or the Gini index. As a single node, n representing the training tuples in dataset D. If the tuples in D are all of the same class, the node n becomes a leaf and is labeled with that class. Note that steps 4 and 5 are terminating conditions. All terminating conditions are given in the algorithm. Otherwise, the algorithm calls attribute selection method to determine the splitting criterion. The splitting criterion tells us which attribute to test at node n by determining the best way to separate the partition of the tuples in data. The splitting criterion also tells us which branches to grow from node n with respect to the outcomes of the chosen test. More specifically, the splitting criterion indicates the splitting attribute and may also indicate either a split point or splitting subset. The splitting criterion is determined so that ideally the resulting partitions at each branch are pure as possible. A partition is pure if all the tuples in it belong to the same class. In other words, if we split up the tuples in D according to the mutually exclusive outcomes of the splitting criterion, we hope for the resulting partition to be as pure as possible. The node n is labeled with the splitting criterion, which serves as the test at the node. A branch is grown from node n for each of the outcomes of the splitting criterion. The tuples in D are partitioned accordingly. There are three possible scenarios: A be the splitting attribute, A is a continuous valued, A is a discrete valued, and a binary. Screen. There are three possible scenarios. Number one, A is discrete valued. In this case, the outcomes of the test at node n correspond directly to the known values of A. A branch is created for each known value Aj of capital A and labeled with that value. Partition Dj is subset of class labeled tuples D having value Aj of capital A. Because all the tuples in a given partition have the same value for a A. A need not be considered in any future partitioning of the tuple. Second, A is continuous valued. In this case, the test at node n has two possible outcomes corresponding to the conditions. A is less than or equal to split point and A is greater than split point respectively. Where split point is the split point returned by attribute selection method as part of the splitting criterion. Number 3, A is discrete valued and a binary tree must be produced. The twisted node n is a form of A is the element of SA, where SA is a splitting subset for capital A, written by attribute selection method as part of the splitting criterion. It is a subset of the known values of A. If a given tuple has value Aj of A, and if Aj is the element of SA, then the test node n is satisfied. Outcomes of the test node at node n correspond to directly to the known values of A. Therefore, it is removed from attribute list. A is continuous value. The test at node n has two possible outcomes corresponding to conditions A is less than or equal to split point and A is greater than split point respectively. A is discrete valued and a binary tree must be produced. The tested node n is a form of A is the element of SA. The right branch out n is labeled number so that D2 corresponds to the subset of class labeled tuples from D that do not satisfy the test. The algorithm uses the same process recursively. The recursive partitioning stops only any one of the following terminating conditions is true. Number 1, all of the tuples in partition D belong to the same class. There are no remaining tuples on which the tuples may be further partitioned. Number 3, there are no tuples for a given branch, that is, a partition Dj is empty.